Okay, good morning, everyone. So this is Dr. Supanay Shirgupe, Head of the Department of Electrical and Electronics Engineering, SG Balekundra Institute of Technology. So today we have with us a distinguished speaker, Dr. Sanjeev Kumar Are from PTA College of Engineering, Gulbarga. So he will be delivering a talk on power system studies and opportunities in power sector in today's webinar. Respected Principal Sir, Dr. Sidramappa VET, the guest speaker of today's webinar, Dr. Sanjeev Kumar Are, dear faculty members and dear students, I extend a very warm welcome to the webinar on power system studies and opportunities in power sector, hosted by the Department of Electrical and Electronics Engineering Department, SGBIT, on 21st April 2020. I would like to thank Dr. Sanjeev Kumar Are for having accepted our invitation in such a short notice and making it to be a part of today's webinar. I thank you, sir. Next, I would like to quickly brief about the very purpose behind hosting this webinar. Now, as we all know that today's electrical power market is highly competitive with a lot of focus being put on the cost, the reliability, and the efficiency. So this calls for a thorough understanding of the practical realities behind the theoretical solutions, which again involves a lot of analysis and planning. And this is where the role of an electrical engineer comes into play in achieving the goals. So with this in mind, the department thought of organizing or hosting this webinar on power system studies and opportunities in power sector. So I welcome you all once again. Stay home, stay safe, and enjoy the webinar. I request Professor Naresh to take the.
Good morning, one and all. Respected Principal, Honorable HOD, esteemed speaker, my beloved faculty, and my dear student friends. So today we all digitally gathered here where we, the Department of Electrical and Electronics Engineering, would like to take an online as a platform for organizing this webinar. It gives me an immense pleasure to introduce today's chief guest, Dr. Sanjeev Kumar Are. Sir had done his master's from NIE Mysore in 2010. Sir had both teaching and industrial experience. Sir had worked in various cadres from maintenance engineer to assistant engineer in VSL Steel Limited in Chitradurga. Sir presently working as an assistant professor in PDA College of Engineering, and he had a past experience as an assistant professor in SDMIT College of SDM Institute of Technology, Ujre. And Sir had published several papers in international journals. Sir had published 11 journals, which is all are reputed, and 9 international conferences and 10 national conferences. Sir had guiding several UG and PG projects. So this is the brief introduction of Dr. Sanjeev Kumar Are. Sir, I welcome you again for the webinar. Sir, this is the platform for viewers. Now you can start.
Able to see Naresh?
Yes, sir, please on your webcams.
Yeah. Yeah, able to see?
No, sir,
Yes, sir.
Yes, sir.
Yeah, visible.
Yeah. Good morning, everyone. I'm very happy to deliver a lecture on the core field of power system. And a very good morning to the principal of SGBIT and head of the department electrical and electronics, and my friend Naresh, and the faculty who are online, and my student friends. So directly I will come to the topic. Naresh, able to see the screen?
Yes, sir. Sir, please enlarge that.
Sorry?
Please enlarge that, sir.
Able to see the PPT now?
Yes, sir. Yes, sir. Yes, sir.
Yeah. Okay.
Yes, sir. Continue, sir.
Yeah. Good morning, friends. The topic is importance of power system and opportunities in power sector. Already, your Naresh sir had given introduction about me. I'm Sanjeev Kumar Arye, working as assistant professor in PDA College of Engineering, Kalburgi. And in shorts, like I heard that even fourth sem students are present here for the presentation. So I will be discussing a few basic things. Then the senior, like say 6th and 8th semester students can get the knowledge of some new things. So first, before getting into the actual topic, since 4th sem students are present, shall see what is power system. Now you might be having or might have studied a subject of electrical power generation. There you will be getting a knowledge like how the power is generated from different sources. Sources means there are two types of sources. Already you might have gone through it: non-conventional and conventional energy sources. So the intention of that is to generate the power, electric power, to deliver it to the required customers. Now, power system. The definition of power system is it starts with the generation and ends with the distribution. I mean, in between you'll be getting the transmission. Say, power system is a network which includes the generation, transmission, and distribution. So altogether, it's called as power system. And why to go for studying this power system? Now, like just I gave the definition of power system. Say a power system is a network which includes the generation, transmission, and distribution. Next stage is why you want power. Say now we are able to, like I am able to deliver a lecture to you by using a laptop, and that laptop can be charged through, say, the power. I mean, the battery will be there in this, and that battery will be charged by the power supply. And for that, power is necessary. So this is a simple, basic example. And next, this is what like all like we have addicted to the electrical power now. Like without power, nothing can be done. This is the situation. And after that, say after looking into the definition and why you are need to have a power system, then importance of it, then can go for analysis, like how to analyze the system, and then the protection required for that. Then we shall look into the opportunities and the challenges. say this is like a platform where you can see what is power system, what is the use of power system, and how and all you can look into the things which comes in the power system. And here the study of power system, just like what you have studied from engineering, like if you are in third or fourth semester, like fourth semester, you will be studied like electric power generation. Then you will be studying transformers and induction machines, DC and synchronous machines. So till fourth semester, this is the flow. Then after that, the power system is extended with transmission and distribution subject. Then power system analysis and stability. Then you will come to computer applications to power system. At the end, you will be studying power system operation and control. So that is a one flow where you will be starting from the generation, then the components used for generation, then the components used for transmission, then transmission and distribution, and at the distribution, you will be studying about the load point and other analysis. Then once the power is sent from the sending end to the receiving end, like what are the problems you are going to face that you can study, then how to analyze the system can be seen, and what are the things used for protection also can be seen. So this is one like type of source from which you can generate the power. But if you start using these sources, say oil or natural gas, coal, nuclear energy, all this got limitation. Like you can use it, but with the continuous usage, someday like it will be vanished. So need to go for the alternate energy source, that is say renewable energy sources. And renewable energy sources are those like you can use it continuously, and its maximum things are like nature friendly. So where you will come across wind power, solar energy, geothermal, biofuels, and hydropower. And these are the different sources where you can generate the power, electric power. And see here, like why? Let us come to this control later. See power system transmission. Okay. So once you're done with this, why you need to have a control on the power system? So you might have seen this power triangle. What do you say, power triangle? If you draw the triangle, say true power, or what do you call it as active power, and this is reactive power, and this is the hypotenuse which represents the apparent power. So true power or active power or watt-full power, what we call it as, can be represented in terms of watts, because that is the power which we can use and which we can measure. Or for the bill what we are paying from your houses for the utilization of the power is through based on this one. And reactive power is represented with VAR, volt ampere reactive. And apparent power is say VA, volt ampere. The best example, say first thing, you cannot see the electricity. Electricity can be like you can feel the electricity. That is the only thing what can be done. But once you feel, later things will be different. Actually, if this was one-to-one conversation, I would have been very happy. But time being, we got a option like this, so I'll be trying to interact with this, because direct interaction will give the more encouragement. Okay. See here, this is one example. Say some liquid with some foam. The actual liquid can be considered as the active power, and the foam above this can be taken as the reactive power. And if you take this hypotenuse level of this one, this is the apparent power. So this is the best example which you can define the electrical power. Okay, say the active power can be measured in terms of watts. Say you can say 10 megawatt of generation. So that is like known thing. And reactive power has to be measured with it. Like reactive power will be present in the active power, but you cannot check how much it is. So this is a way, one way of representation. And so these are some lines. Electricity has to be generated the instant is consumed, since there is no practical storage of electrical energy. And the general requirements of the operation of power network are that the frequency and voltage can be maintained within the desired limit. So this is one main important thing. When power is sending from a generation to the, able to see a hand raise it here. Okay. Now someone is having a doubt, I guess. Yeah. Okay. Thank you, ma'am. We'll proceeding with this.
Yes.
Next is next is the general requirement of operation of power network, that the frequency and voltage can be maintained in the designated limits. Why we are concentrating on the frequency, why we are concentrating on voltage is important, because there is a single line diagram. With that, I will be explaining clearly, like what happens when say load got increased, what happens when load is decreased. Okay, I will explain. I will be explaining that in the next. Fine. Next is automatic control system, or therefore necessary in all power system. Like now we are using the SCADA, PLC and SCADA, programmable logic controllers and supervisory control data acquisition system. So that is a new trend which is being used now. And these are the some basic knowledge for transmission, because we got generation. After the generation, say the power generated power has to be transmitted. So here you got the transmission system with some levels of voltage. Say here you can see this is a power which is being generated, will be given to a transformer. Say definitely it has to be a step up transformer, because the generated power will be with the low voltage, low voltage level, that has to be stepped up for a higher level for transmission. So once you go for the transmission, then it will be reaching to another transformer at the substation, where the voltage level will be stepped down, and that is given to the next transmission system from the distribution network, to the distribution network from the substation. So these are some voltage levels, say 400 kV, 275 kV, in between you will get 220 kV also, 132, 66, 33, 11, 6.6. See, all these are the different levels of voltages. And the voltage at this level, 400 kV, is super grid. Means you might have heard of Power Grid Corporation of India Limited, PGCIL. So that is a one central government sector where the power will be taken and it will be transmitted to the different different substations, which is under the control of central government. And what we have, the 220 kV substations in our nearby areas, those are under the control of say SCOMs. Before that, it is KPTCL and SCOMs. And here you can see high voltage. Usually we will bifurcate high voltage and say low voltage. You might have seen in the road like LT line lies or HT line lies. So the LT line means the voltage will be below 1000 volts, 1000 volts. And the voltage above 1000 volts is called, say, high voltage. So imagine just 1000 volts, above 1000 volts is a high voltage, and here the grid will be having, say, 400 kV of voltage. Okay, 1 kV is a high voltage, and here you can see 400 kV is the voltage. And see, just this 440 volts, this is the only voltage which is, you can call it as low voltage here, and from 6.6 it's already a high voltage, and there you can see small scale distributions will come with 6.6 and 11 kV. Even 3.3 kV voltage is also available, but the 3.3 kV is used in the industries. And next 33 kV, 66 kV. This is a major distribution where the substations will come. Connection to the substation to the distribution system. And say this is 132 kV, usually will be going for transmission, and 220 kV is again transmission system. 400 kV comes under the PGCIL. Okay. Yeah. I will brief out some like types of transmission. Say overhead and underground transmission. This overhead means like what you can see with the steel towers or the electric poles. Okay, that is overhead transmission line made up of ACSR conductors. Okay, and the transmission line is made up of ACSR conductor. That is a material. And AC transmission, DC transmission. Those are the types of transmission. Okay. And after overhead, there are underground transmission also, and that is done through the cable, underground cables. Okay, and those cables will have different capacities, and based on the type of supply, say AC transmission and DC transmission. And what we use in India is AC power, and transmissions are available with both AC as well as DC. And even in our Karnataka, there is a line from Kolar. From Kolar, you can see a line, HVDC line, which is being connected to the other state. Okay, and based on the length of line, we'll be classifying with long, short, and medium transmission lines. Okay, and just if you see one picture of the tower, so these are the transmission lines which are made up of what do you say, ACSR. Okay, then there will be a neutral line. Usually the top of the line, what you can see at the top is usually a neutral line, and these two will be say phases, and it will be you having the three phases RYB with a neutral. But here it has been bifurcated and shown as say sub transmission lines, and distribution primary V plane is there. So even capacitor bank has been shown here. So all maximum things have been covered in this pole. And this is a system where you can see this. These are called as steel towers, and these will be used for a high voltage level, say up to 500. 500 kV and above. Even for 400 kV, we'll be using the same. And up to 230 kV, you can go for using this type of lines, like double pole lines. We'll see double pole transmission. Connected with the transmission. Next is 132 kV, 69, 33, 11 kV. The lines which you can see near to your houses are of 11 kV. Okay. Next is the distribution system. Say you have seen generation. Generation can be done with the different types of sources, say conventional, non-conventional energy sources. And the voltage level, I didn't say this actually. In the generating system, you can have a voltage level up to 11 kV in India. That is preferable voltage level for generation. You can generate the power with 415 volts. You can generate the power with 3.3 kV, or you can generate the power with say 4.6, 6.6. Maximum should be 11 kV. After 11 kV, if you go for generating power in India, say it will be costly, and economically it is not feasible. Okay, so we will be restricting the voltage level to 11 kV at the generation side. Then from the transmission, say we will be going for 132, 220, 400, and there is a line of 765 kV also in India. Okay, so that is a transmission line. In that we'll be bifurcating as primary and secondary transmission. Then we'll come to the distribution. At the distribution, we'll be having 33 kV, 11 kV, and that 11 kV is again subdivided into 415 volts. Okay, and at the distribution level, you will be having a substations, and those substations are classified based on constructional features, based on service requirements, like that. Okay, so here based on constructional features, it is divided into indoor substation, outdoor substation, underground substation, pole mounted substation. So this is indoor substation is like a substation, entire substation is built within a closed area, like just like in a big hall, the substation will be mounted. Okay. Next, outdoor substation is the one what you can see when you're walking through the road, or when you're traveling through the road. Beside, you will be able to see the substations. So those are called outdoor substations. All equipments will be exposed to the weather, like transformers, circuit breakers, everything will be directly exposed to the weather condition. But the things which can be used in outdoor substation, the things which can be used in indoor substations will be different. Okay. Next is underground substation. So indoor is one. The substation will be erected inside a room, like inside a hall. Underground substation is below the level of say the earth, what we can use. We will be making like they will be making the underground thing, and there they will be going for installing the substation. This is only to save some the land in the city. Will go for metropolitan cities can go for this. And next is pole mounted, means entire substation will be erected on the poles. So that is pole mounted substation. And in Karnataka, there is a underground power plant named as Varahi hydropower plant. If possible, you visit it. That is the one best and important substation to visit for the electrical engineers, because their entire substation is erected. So not substation, sorry. Entire generating station is erected in in the underground. Okay. Next is based on service requirement. See, that is based on construction features. We'll be dividing into indoor, outdoor, underground, and pole mount. Based on service requirement. Service requirement means like how you want the service. Okay. So that is transformer substation, means the substation which is done with the transformers. Switching substations, say which will be changing the levels of voltage from one level to the other level. Then frequency substation will be based on frequency, and converting substation. Converting substation is used for HVDC stations, where you will be converting AC to DC and DC to AC. Why you need to have DC to AC or AC to DC is, in India what we use is AC power. And suppose like DC transmission is useful when you go for high level of voltage transmission. Okay, when you go for a transmission, high voltage transmission above say 500 kilometers, say you can use HVDC for transmission. So that will be economically good and economically advantageous compared to AC system. So when you go for that, since we are using AC power, AC has to be converted into DC and DC has to be converted into AC. You know very well, say conversion of AC to DC is rectifier and DC to AC is inverter. Same, we'll be using a rectifier station and inverter stations. So this is a schematic representation of single line diagram of a power system. See, I will tell you the clear thing here. So this is the generation where the power is generated, and I told the voltage should be up to 11 kV in India. You leave about these voltage levels because this is just a picture which is taken from the net. Okay, I will be telling the actual voltage levels. So generation up to 11 kV you can go for generation voltage. Then there is a transformer, say step up transformer, and that is a step up transformer where the level of voltage will be stepped up and given to the transmission system. So till here it can be up to 11 kV. From here it has to be minimum 110 kV, 110, 220, then can go for 400 kV lines. Then here there is a transformer which is usually a step down transformer, which is used at the substation. And after stepping down the voltage, it can be converted. Say example, 220 kV can be converted into say 110 kV or 132 kV or say 66 kV, whatever the required voltage, and that can be given to the industries here. Okay, so these are the industrial customers. Then the same power is transmitted to another transformer at the distribution level, where the voltage can be converted into 33 kV or 11 kV. From the 11 kV, again it will go to 415 kV, and from the 415 volts, not kV, 415 volts. And from the 415 volts, 3 lines will be taken, R, Y, B with neutral. And if you take a voltage between 2 lines, you'll be getting 415 volts. And if you take a voltage between 1 phase and 1 neutral, you should get 230 volts. Okay, so in our houses we will be using 230 volt AC supply. So for our home, I will be telling in the next slide how you are going to receive supply to your home from the generating station. So at your home you will be using single phase 230 volt supply. Okay, and same thing like see, this is a single line diagram. See, this generating station entire thing is represented with a symbolic representation of a generator, and what symbol should come. If it is AC, you will get a AC symbol. Okay, sine wave. And next you will be having a transformer where the power will be stepped up. Okay, and this is a breaker, circuit breaker used for protection. And this arrow mark is nothing but a load point. Okay, and transmission line where the power is being transmitted. This is another interconnected load, and these are the breakers. These symbols of breakers will be given to a transformer again. So voltage will be stepped down and given to sub-transmission lines. And again here, one more transformer for the step down and given to the industrial loads. And further the same line has been continued here to the distribution transformer. And from the distribution transformer, it is divided into, like it's given to the different transformers and given to the load point. Example I told, so here it is industrial load. And here when you come to this, usually this will be say 66 kV or 33 kV, and this is a transformer, or it will be 11 kV, output will be 11 kV. So that will come to the transformer near to your home, where it is converted into 415 volts. The primary side may be 11 kV or 33 kV. Secondary side it will be 415 volts, and that 415 volts will be having, as I told, you'll be having 3 lines R, Y, B with neutral. And if you take voltage between 2 phases R and Y, you should get 415 volts. And if you take phase and neutral, you should get 230 volts. Okay, and that is what you need, 230 volts supply. Okay, this is the thing, like how the power reaches you. That is what I was telling you. See, this is a power plant where the power is generated by either by conventional or non-conventional energy sources, and that is given to the transformer, then transmitted, then given to the primary grid. I will come to this. Okay, grid. I will come to this topic later. Just for time being, have that in your mind. It's a primary grid. Then that will come to say 66 kV line. Then it will come to, say, this is 66 kV substation. And here 66 kV is converted into 11 kV. See, this is a primary distribution of 11 kV. And this is a transformer where this 11 kV is converted into 415 volts. This is not kV, 415 volts. Okay, 0.415 kV. You can take like that, or 415 volts. And this is given to your home or your house. See, from here, 415 volts means, I said, 3-phase supply or YB with neutral. Same thing will come. And near to your home, say for some 10 houses, the supply can be given from R phase and neutral. For next 10 houses, it may be from, say, Y phase and neutral. Another 10 houses, it may be from, say, B phase and neutral. So R, Y, B are the three phases, and given the load is distributed equally among the transmission line. Now you can get a small doubt that what is the situation if all the 10 houses of one phase are being turned off or switched off. Okay, so these are the things questions should rise in your mind. For that, you'll be going for balancing the phases. Phase balancing, relays will be used. Okay, so that has to be balanced. And like this, so for that reason, what the people will do is, for the residential load, one phase will be given. For another phase, they will be going for, say, street lights. So like that, bifurcations they will do. Okay. And this is transmission and distribution in India. See, this is, I will give you the picture how the power is generated, transmitted, and distributed in India. Okay. The India is divided into, I mean, the country is divided into 5 regions, mainly 5 regions: northern region, southern region, eastern region, western region, northeast region. Okay, these are the 5 regions. The India is like classified into 5 regions for power sectors. Okay, see, you can see that yellow colored covered area. This is northern region, and we comes in this southern region. So like that, the regions have been divided. The states, some combination of states have been divided for generating, transmitting, and distributing the power. Example is like we got thermal power plant in Raichur, and there is a nuclear power plant in Kaiga. The power which is being generated in Karnataka is being transmitted to the, say, northern region. Okay, so generation is done in southern region and it is being transmitted to northern region. So that is an agreement which is made way back. Okay, and even the Karnataka people are having a power station in Chhattisgarh. That is a newly new. This is around 7-8 years back. They have erected a plant in Chhattisgarh. Okay, so like that, some 40 or 50 years back, the North people have erected their power plant in Karnataka. So power has to be supplied to them. Okay, so these are the 5 regions: northern, southern, eastern, western, and northeast regions. And all these regions will have again ESCOMs. Example, in our Karnataka, we got KPTCL. Before it was KEB, Karnataka Electricity Board. Now it is like KPTCL, and that KPTCL is looking after only transmission system, and all other distribution system network is being looking after by ESCOMs. Say BESCOM, HESCOM, MESCOM, SESCOM, like that. Like Bangalore area is like MESCOM, Bangalore area is BESCOM, and Hubli Dharwad area is HESCOM. Mysore region is MESCOM. So, sorry, SESCOM, Chamundeshwari. So, like that, further ESCOMs have been divided or bifurcated. And next, the control. See, those are the 5 regions with the electricity boards, and then come to the control. Control is, as I told, like Power Grid Corporation of India Limited, PGCIL, which is under the central government, is controlling all these regions. Okay, and this is connected with the LDC. LDC means Load Dispatch Centers. Load Dispatch Centers are connected with the ALDCs. ALDC means Area Load Dispatch Center. Okay, so example, we got a load dispatch center at the Bangalore, and that is having control on all the state boards, say BESCOM, HESCOM, JESCOM, everything. ALDC is the one which will be looking after a particular ESCOM. Okay, so like that, all BESCOM, HESCOM, SESCOM, JESCOM, all those ALDCs will be connected with the LDC, and they will be managing the power. And that is like if they want, they can connect it to the Power Grid Corporation of India Limited for the generation and transmission of power. Like whatever the power which is generated will be transmitted to different places where the power is required. And grid, I told. See, grid is a network where the generating systems are connected, or where the power is being connected. That place we call it as grid. Okay. So initially, this was a local connection, means generate the power and connect it. This was in 1950s, and in 50 to 60s, states grids have been started. I told grid is a network where it's a meeting point or a junction where the power, generated power, can be interconnected. Okay, so state grids have been started, and in 70s to 80s, regional grids have been started. Then in the 90s, like interconnection of regional grids. That is what regional grids, nothing but I told like 5 regions. Okay, and that was with individual control. Next in 90s, those like northern, southern, all the regions have been interconnected. In 2000 onwards, it's national grids. Say one nation, one grid. That is the trend which is being followed nowadays. Okay. Why you want to interconnect these grids is, example, like I will be having sufficient generation, like sufficient load, so there is no problem. Suppose if you're having excess of generation and the connected load is less, then the power which is generated can be wasted. So that can be transmitted to the one where the power is required. Okay. Another option is like you don't have sufficient generation in your area, but load has to be operated compulsorily. So you can purchase the power from other interconnected grids. So with these all things, they have gone for interconnecting the grids. It's just like when you have sufficient money, you can give it to your friends. Later, when you are in need, you can take it back. So same procedure is being followed here. That's all. Okay. And the levels of voltage. I told when you go for high voltage or when you go for increasing the level of voltage, the advantage is the losses will be reduced. Especially in the transmission system, the losses can be reduced by increasing the level of voltage. That is why we should concentrate on high voltage and long distance transmission. Okay, so here in 1977, like 220 kV was the maximum voltage, and in 1990 it came to 400 kV. In 2000, 500 kV with HVDC. I told there is a line in converter station in Kolar. Okay, there is a HVDC station. There the voltage is 500 kV, 500 kV DC. And in 2002, till 2012, this was 760 kV. This was the highest voltage in India for the transmission system. Okay, and again in 2017-18, 800 kV HVDC voltage. Okay, and same thing was connected with 765 kV DC to AC voltage. So this is a line, 765 kV line. We upgraded with the HVDC system, say 800 kV HVDC with 765 kV DC system. Okay, and the world's highest voltage level charged in October 12. Remember, October 12, 2019, 1200 kV. This is the highest voltage, but still it's in the test condition. Now it has been brought in the picture. Okay, so that is 1200 kV of voltage. Till now it was 765 kV voltage was the high voltage in AC. Now you will be able to see 1200 kV volts. Okay. Next is, say now you are done with, let's say, generation, transmission, distribution, and how the power is generated, transmitted, and distributed, and how you will receive power to your home. Now, the power is generated, transmitted, and distributed. But in between, it crosses a lot of problems, say, that can be analyzed with fault analysis. Say, to determine the maximum current during fault, which helps in design of circuit breaker and other equipments. So, when you're going, like example, when you're constructing a house, if the like first we'll go for basement, and if the soil is not so stiff, we'll be going for, say, pillars. So like that, when you're going for a power system to transmit or generate the power, you should use the proper components which gives protection to it. So circuit breakers are those which makes or break the contact, okay, depending upon the input given by the relay. Next, automatic detection, restoration of faults with intelligent electronic devices. So this can be done. Example, say this is a transmission line somewhere away from the generating station. Example, assume that one line got fall down due to, say, a tree might have fallen on it or some natural disorder. How to find out like where the fault has been occurred? For that, we'll be using distance relay. So like that, there are different protecting devices or components which can be used for these purpose. Okay. So all these fault analysis can be studied in power system analysis and stability. And till now, what you understood is with the electric power generation EPG. Next was with, say, transformers and induction machines, which are being used for generating the power. Next is DC and synchronous generators, then transmission and distribution. Then with that, then we'll come to the switch gears, then power system analysis and stability. Then we will be going for computer applications to power system stability, and then power system operation and control. So that is a flow. That is why the subjects have been kept like that in electrical engineering, to understand each and every step clearly. Okay. And protection, that is what, say, all these things you will be able to see. So these are the relays, different types of relays: HRC, HBC, fuse, glass fuse. Okay. So all these, sorry, not relays, these are the fuses: HRC, HBC, then glass fuse. These glass fuses are used for low voltage applications. Okay. Just if you take a stabilizer and open that, you'll find this glass fuse. And HRC is high rupturing capacity fuses. HBC is high breaking capacity fuses, and these are made up of semiconducting materials. Okay, this high rupturing capacity is made up of semiconducting materials. Okay, and these few things which you can see are the relays, and these are called add-on blocks. Add-on block means NONC contactors. Okay, normally open, normally closed contactors. And these things, like the fourth sem students may feel like it's away from your head. Okay, but just have a glance, have a look on these things. Later in your future subjects, you can go through it. Okay, and sixth sem and eighth sem students will be familiar with these things. And see here, in the protection, when the protection come into the picture, say current and voltage. Say current is the one which is going to change when a fault occurs, and voltage is the one which is related with the current, which will also change. Okay, so based on the current rating and voltage rating, that is why all the transmission lines will be rated based on their voltage levels, and the devices what you are going to use as a load will be based on the current, based on the value of the current it draw. Example, the motor which is used for, say, lifting water from sump to the tank, that can be that you'll decide that motor depending upon the HP capacity, like half HP motor, 1 HP motor, and the current rating from half HP to 1 HP will differ. If current capacity is increasing, means the lifting capacity of water will also increase. Have that in your mind. Okay. So next is with the circuit breaker, batteries and fuses. That is what I told. These are the protecting devices which you are going to use. And protective relays. There are different relays you have studied in switchgear and protection. Based on construction, again it is bifurcated. Based on the operation, we are going to bifurcate the relays. Okay. That is available in switchgear and protection. Okay. I got a very less time here, so I will be covering this. So the same thing has been explained here. And with these current and voltage transformers, see, these are the things which you can use it for measurement as well as for protection. Say starting of the substation will be with CT and PT, current transformer. CT is nothing but current transformer, PT is nothing but potential transformers. Say that CT, PT will measure, say what is the current, what is the voltage. By the same time, those will protect if high current flows. Okay. So like that, you will be using the CT and PTs for protection as well as metering usage. Okay. And these are the things already have discussed. And this is one more thing to be considered is primary and backup protection. All systems will have primary and important systems of the power system network will have primary and backup protection. Say primary protection is if something goes wrong, that has to be detected and you should go for protection. Backup protection is one. Say if that primary protection fails, the backup protection will come into the picture and protects the system. It's just like using your mobile. You'll be using a screen guard. So screen guard is your primary protection. If something falls on it, the screen guard has to protect it. If you don't have screen guard, your mobile will be get affected. So you'll be having the primary protection of screen guard. And if the screen guard is not working, again it affects on the mobile. So that is a secondary protection. Secondary protection is your screen. Okay. If screen fails, same. The power system will also fail like as your mobile will fail. Right? See, these are the real pictures of, see, this is CT, current transformer, voltage transformer, and MCBs, miniature circuit breakers, what you can see at your home. Okay, this is single pole MCB, two pole MCB, and three pole MCB. These are digital relay, which will work based on microprocessor and microcontrollers. Then battery units. Even in your mobile, you got a batteries. So the batteries with a high capacity are being used at the substations, okay, or the place where you need to store the supply. And even in your home, for the inverter, you will be using a battery. And those batteries will be classified based on their ampere hour capacity, AH, ampere hour capacity, okay. And these fuses are used for primary protection. And these are particularly for like final year students, okay, power system security studies. 4th and 6th sem students cannot catch these points here. Just I will brief out, okay. Power flow. Power flow means you got a network. In that, how exactly the power will flow. What is the active power flow? What is the reactive power flow? And depending upon that only, you'll be deciding the network. And you got a concept of detection of network problem. Detection of network problem in power system operation and control. There you can understand the flow of power. And even in power system analysis and stability, you have done with the calculation part. Then state estimation. This is the next level, okay, of analyzing the fault, analyzing the things, and estimating it. Estimation of the power. Okay. Contingency studies is like what happens when fault is occurred on a system. Maybe single line to ground fault, double line to ground fault, or three-phase fault, whatever. So when fault is occurred, what might be the problem? Analyzing the problem, before the fault occurs by taking some raw data. Okay, that is contingency studies. Next is load forecasting. See, now for today, example like 100 megawatt is sufficient. But after 1 year, what is the requirement? Or after 10 years, what is the requirement? This is load forecasting. And yeah, thank you, sir. Like I thought a question. Fine, I will be proceeding. Thank you, Srinivas Rao, sir. Fine. So here we got load forecasting. Load forecasting is like prediction of the load in the future. Say after 10 years, what is the case? After 20 years, what is the case? Or after say 50 years, what is the requirement of the power depending upon the load? Okay. Next, interchange schedule already I told. Like when you have the excess of power, give it to someone. When you are in deficiency of power, take it from. That is a interchange. Next is generation, dispatch, and control. So when you go for this interchange operation, interchange schedule, you should know what is the power being generated, what is the load connected. So all those things will be done by generation, dispatch, and control. And the next is fault level analysis. Like what is the type of fault which may occur in generator? What are the types of faults which will occur in transmission system? So like that, you will be bifurcating and you will be studying and analyzing. Okay. Next, optimization techniques. This is a trend and area where maximum research have been continued. Even my area of research was related with this. So like this, there are different areas of research which can be done with the problem of optimization techniques. Okay. And this is a layout. See, already you have seen all the generation, transmission, distribution system, analysis, fault prediction, then controlling. Okay. So this is a single line diagram which can be drawn. Say ACSR conductor, I told, transmission line, which is connected to a lightning arrestor. Means when lightning comes, the system should be get protected. So we'll be using lightning arrestor in the beginning. Then you will be having a switch. Usually that can be called as a GOS, group operating switches, okay, or gang operating switches. Okay. Then you'll be having a primary protection of fuses, then transformers, then again a switch, circuit breaker, and there are different types of circuit breakers: oil circuit breaker, SF6 circuit breaker. Okay, so depending upon the type of substation or the components what you are using with that. Disconnection switch, lightning arrestor, ACSR conductor. So this is a layout which is being used and followed. Now, till now we have seen like the power system and generation of power and reaching it to the load point. And there are some issues and challenges here. Say the fuel quality. If you're using thermal power plant, the coal should have a good quality. Example, like if you leave, if you go for wind power plant, sufficient wind should come. So like that, fuel quality and availability. Then power generation technology, like how the power is being generated, with what. Example, if I ask in a thermal power plant, which generator to be used? Definitely you will be knowing it's a synchronous generator. And some of the students like even I will see these things. If I ask which is the generator being used in nuclear power plant, for this question, maximum will fail to answer. Same synchronous generator will be used because concept of getting the heat or temperature is different, but the generator what you're using for the steam turbine or the generator what you're using it for the turbine is synchronous generator. So like this, And now the trend is changing. In wind power plant, it was induction generator before. In a wind fan, the usage was with the induction generator because of variation of the wind. So that generator has to handle for fluctuation of the wind. That was not possible with synchronous generator. Now with the help of power electronics converters, power electronic converters means that includes AC to DC, DC to AC, AC to AC, and DC to DC. Okay, everything will come. So converter, power electronic converters. Now synchronous generators are being used in wind power plant also. So that is a trend. So that is called power generation technology. Next is land acquisition problem. You will be knowing very well. Okay, like to select a area to erect the power plant. Next, logistic route rail, and means there should be transportation facility, and grid should be near to that. Water source, sufficient water source should be there, and definitely when you go for purchasing it, you're looking into the economy. Say price of fuel should be less, and environmental friendly. All these things cannot be fulfilled, but still we'll be looking into the maximum things to cover. Okay. So next is career. You will be finishing, you will be doing your BE in electrical engineering. Next, what to do? So that is a question. There will be many ways, say colorful ways. You can see the colorful arrow marks here. So electrical engineers options. There are many things here. You can have a look into the things. You can decide what to do after, or in which sector to enter after electrical engineering. Okay, don't think that you don't have job. Don't think like you got job only in APTCL or only in, say, some generating stations. Now these are all these, and the advantage of electrical engineers is you can get into the IT sector, you can come to the core, but my suggestion is be in core field. Okay. And see, this is with a small thing like field. If you choose a field of job, you can go to private sector, public sector, government sector. Research, if you want to do, you go for higher studies, MTech, PhD. Or best thing is you get into some companies like ISRO, BARC, DRDO. There you can join as a scientist, and there you can pursue your PhD, everything, higher studies. Okay. Next is management. If you want to go in the side of management after BE, the people with engineering background with MBA or given a preference. Okay. So management, if you side, if you want to go MBA operations, PGDM in marketing, training institutes like NIC, MEA. So these things you can choose. And if you go to the private sector, say there again it is divided into design, development, testing. Okay. Then in the industry like manufacturing, production, highways, airports, okay. Then automation, water source, construction, planning, management. So those are the private sector jobs. And public sector for particularly electrical engineers in core field for these NTPC, NHPC, IRCON, RITE, SAIL, BHEL, okay, all these things, HPCL, GAIL, okay. So these are the public sectors where you can go for electrical engineering jobs. Okay. Industrial interface, like if you go for this office interface versus industrial interface. So office, if you go for like a type of data will be textual, in industry it is numeric. Rate of change in office is slow, in industry it will be fast. Environment in the office will be having a AC, okay, it will be clean, but in industry you cannot expect that. Okay, it's like the oil soap mouse. So indirect manipulation, direct manipulation. See, office is like a direct manipulation. User interacts with the artificial world system. Industry is like indirect manipulation. User interacts with the real world through interface, and issues feedback delays. Say the best thing I will tell you, you will be like some of the people will be completing degree in electrical engineering, and they will be getting a job in IT sector by doing a course in Bangalore or somewhere. And after getting into the IT sector, I will tell you the beauty of what is that, software engineers. They will be given a very good salary, smart salary, and they will be given some part of a work. Remember, it's a part of a work, and that part of a work was divided by the team leader, and that team leader's part is again divided by many, like among many team leaders, say some 10 team leaders, and upon 10 team leaders there will be some 10 managers, and for those 10 managers again it was divided by some senior managers. So like this, like that, one part is divided into say some minimum of 100 pieces, and you will be doing a work of one piece. That is called coding. You'll be coding, but don't know what it is. Okay, so that is a beauty of IT sector and IT people. That is why they will be getting a smart salary, but they cannot open their own industry because they will be knowing only one part. At the max, when they come to the team leader position, they will be knowing 10 parts of 100. When they come to senior manager, say some 20 parts of 100. So like that. By the time they reaches the 100 parts, it's a retirement age. Okay, fine. So be in core field, work in core field, and try to get a job in core field. So though electrical engineers can be operation, maintenance engineer, production, planning, design engineer. So these are the different areas where you can get excel. Okay. Then the industry, like the generation, come across with micro, mini, and mega generation, distributed generation. This is a new trend, distributed generation, DGs. Okay. Then utilization and production, that is with the small scale, small, large, and very large scale industries. Then co-generation. Then switchgear and safety, error and repair. Okay. We cannot always avoid errors, but we can put them in right. Make it easy to detect errors, then the user can repair them. Okay.
Sir, 1 minute. Vishwanath Kore,
Yeah.
you need to ask any question? Vishwanath.
Hello, sir. Good morning. Yes, sir. Good morning, sir.
Yeah, you
good
please
morning.
ask.
Go on.
Sir, can you please go to the slide after the career section?
Where here?
No, yes, sir. Yes, sir.
This one?
Yes.
Yeah, yeah.
I'll just take a pic, sir.
Okay, okay. I will be sending the PPT to your sir. Okay.
Okay,
If you
sir.
want, you can use it. Now you take a pic, no problem. Like I will be sending
Okay.
the what is that PPT to you. Huh?
I have taken,
Any
sir.
other
Thank you so
question?
much. No, sir.
Yeah. Any other question?
No, sir.
I
Thank
know,
you so
like
much.
you might be. Yeah, fine, fine. Okay. Shall I proceed, Naresh?
Yes, sir. Yes, sir.
Yeah. Your students might be feeling bored because, like, it was with one-to-one conversation. I might have enjoyed, and they might have enjoyed like anything. Okay.
No, sir. They are listening. They are
Now,
attentive, sir.
yeah, but still, I am not satisfied with just with one way of conversation. You know very well, right?
Yes, sir.
Okay. Yeah, fine. So this is just a pic of control panels. Okay. In the industry, you will be able to see these things. This is a control panel example. Say if you take only this one, okay, this will be having a breaker control, and these are the indicators, and these are the meters. Okay, and this is one such thing what you have seen before. Say electrical engineering, concerned with generation, distribution, electric power, control, and instrumentation. And work in the manufacturing industry. Manufacturing means the components which you can manufacture. Okay. Design electrical machinery means this is a design field. Okay. Manufacturing is production field, and this is design field. And other things, then work with the equipment that produces the distributes electricity. Same like with the KPDC and all. Then the machines, design electric machines, motors, machinery, and all irrigation systems. And this is one thing. What might have happened on 5th April 2020? You're able to remember like what was the thing was announced by our Prime Minister and what is that on 5th April 2020? Yes, our Prime Minister have announced it like our Prime Minister announced, say all of you should switch on the lights and you should go for lighting the lamp, right? See, these are the pics which have been taken on that day from KPDC website. So this was the demand and this was the generation. Okay, so generation, sorry, which got dropped out, and this is the thing which you can see. And here, this is the unbelievable and first time the people were able to see the frequency of 50.25 hertz. Okay, first time. I mean, maximum loads were shut down and the generation was excess. Definitely the frequency will come up. And this is the state demand 7116. Okay, and generation was 4050. So that was a thing before and came to this. There are two things. Yeah, before I finish, these are the two things what I want to see when tell you. Say blackout and brownout. You might have heard of blackout. It happened some 4 or 5 years back. Say entire northern region was with dark for 46 hours. Okay. Say almost for 2 days. It was without power, and that was happened because of failure of one generator. Okay. Since all the generators were interconnected, failure of one generator leads to failure of the another generator. So the load on those two generators has been put on the remaining generators. Again, one more generator got failed. So like that, series failure of generators happened, and that was made as, say, called as blackout. Okay. And brownout is the one intentional shutdown. Like you will be taking out the generator for maintenance. So that is brownout. So these are the two new things which you can see, blackout and brownout. Okay. So with this, I'll be ending my presentation. Hope you have got some a small knowledge, and I will be happy like if I come for the direct interaction. Okay. Thank you. If you have any questions, you can ask. Hello.
Yes, sir.
Are you able to hear? Yeah.
Yes. Sir.
Yeah.
Dear
If
student,
your students or someone like having a question, they can ask. I'll be happy to answer. Yeah.
Yes. One of our faculty had been asked, sir, that is why these
Okay.
voltages are 11 kV, 220 kV, 322, like that.
Yeah, that
33.
is a standard. That is a standard like what we Indians are following. Levels of voltage. Example, in our home,
Yes.
household purpose, it's 230 volt single phase supply.
No. That
Why
is
it
not,
is
sir.
230? That is what I'm telling. I'm going to come to that. In our
Yes.
home, it is like 230 volt single phase supply. Means
Yes.
all the equipments what we use for the domestic purpose will be designed for that voltage.
Yes.
Okay. Suppose like if I design say some television with different voltage, and I cannot use it here. So like that, there are some standards. There are
Yes.
some standards to be followed, and that is being same followed in the electric power sector.
Yes. And students, any doubt?
Yeah.
Sir, I'm handovering to my HOD to give a concluding remark.
I have one doubt.
Yes, yes.
Yes.
Yeah, someone is having a doubt.
One.
No. Myself, Charan Basu Maria.
Yes, sir. Yes.
Yeah.
I want to ask Sanjeev Kumar, sir.
Yeah, sir.
Sir, now Karnataka is a power surplus state.
Yeah.
Sir, does that mean we should stop exploring new areas of power generation, or we should stop investing in the power generation?
Question is not clear, sir. Like I didn't get what exactly you're asking.
So now the Karnataka is power surplus state, sir.
Oh, yeah. Like, see, sir, this will be done based on load forecasting. And when there was a deficiency of power, the Karnataka government has taken land in, like, say, Chhattisgarh, and they have erected a plant over there. So now, as of now, with the renewable, especially with the renewable energy source and with the Pavagoda solar power plant, the power has been become like surplus. Before that, it was like we were able to see a lot of shutdown.
Yes, sir.
So it's a plan, sir. I told you 5 regions. All the 5 regions are interconnected now, and there is a single control with the SCADA system, and that will be controlling in the SCADA system. Say if you take LDC, load dispatch center, all the data will be available, like where the excess of generation is available, where the load is required. So they will be managing it automatically. The SCADA system will send the power to the required area.
Okay.
Vishwanath, you can ask the question.
Hello, sir.
Yeah, hello.
Sir, you had said that 11 kV, 22, 33, these are all our standard.
Yeah.
Sir, but I have heard that 11, 30, they are all are multiples of 11, and they cannot be divided by any number
That is
because of
one
form
thing,
factor
like
and
insulator.
RMS factor.
Yeah, we'll be going for like designing of insulators also. Example, if you see 110 kV transmission line, there you will be using a disc type insulator and one extra insulator. It will be having say 12 discs in it. That is also a reason, and we'll be going for that also. What do you say, like the power factor, other things?
RMS factor.
Yeah.
Okay.
Yes, I am handovering to our HOD Madam, sir, to give a concluding remark.
Yeah, fine.
Sir, 1 minute.
Yeah.
Sir, please, sir. Hello, sir.
Yeah, hello.
Sir,
Yes.
please on your webcam. We will take one pic.
Oh, okay. It's on now, right?
No, sir. Yes, sir.
Yeah.
1 minute.
Yes, sir.
Yeah.
Yes. And Madam, so vote of thanks
Yes,
or concluding?
Naresh, sir?
Yes,
Yeah,
madam.
I will give the concluding remarks.
Yes.
Vote of thanks will be given by Professor Marihal.
Yes. Yes.
So I take this opportunity to give the concluding remarks for today's webinar. It was really a very wonderful session, sir. I thank Dr. Sanjeev Kumar R.A. for this wonderful session on power system studies and opportunities in power sector. On behalf of our principal, sir, who could not make it now because of its commitments, I also thank on behalf of myself and on behalf of the Department of Electrical and Electronics Engineering. Thank you so much, sir. You have covered almost all the aspects of power system engineering, starting from generation, then transmission to distribution. You have given an exposure to the ALDCs, SLDCs, and their importance. Then you spoke about the protection schemes, protection devices and schemes, power issues and challenges. Then you also gave an insight into the career opportunities in power sector, which is very much required by our students. And one thing I would like to tell that you kept up with the right pace and right pace that was exactly required by our students, sir. So this was very good. And also you also kept up with the right content coverage. I'm sure that your session has been very much useful to the entire audience, including the faculty members also. And you also discussed about the brownout event on the 5th April 2020. So that was interesting, and I thank you once again. We look forward to have similar sessions from you in the future also. Thank you.
So Professor Shanbasu sir, you please give the vote of thanks.
Good morning, everyone. Respected Principal Sir, speaker of today's webinar, Dr. Sanjeev Kumar Sir, Dr. Suparna Madam, and all my faculty colleagues and dear students. I am Charan Basu Mahaya. I am proposing the vote of thanks for today's webinar. I must thank the principal and management of our college for motivating us to conduct such webinars. Thank you, Principal Sir and management. I thank the speaker of today's webinar, Dr. Sanjeev Kumar Sir, for his valuable webinar session and his valuable time within a short period of time. He has accepted our invitation and he was ready to give this webinar. Thank you, sir. And I thank our HOD madam who encouraged and guided us to conduct this webinar. Thank you, madam. And I must thank Professor Naresh sir who has organized this webinar, and repeatedly he has conducted some test webinar sessions for all the faculty so that we should get well versed and there should not be any glitches in the webinar session. Thank you, sir. I must thank all the faculty members for their cooperation and for attending this webinar session. Thank you all faculty members. And I must thank the students of all the semesters, 4th, 6th and 8th semester who have joined for this webinar. Without you people, it could have not happened. Thank you all the students. And finally, I thank one and all who have directly or indirectly helped for this webinar. Thank you, everyone.
Thank you, sir. Now I will launch that feedback. You please, students, you feel that yes, you please fill this. Yes, thank you one and all. We'll close the session. Madam, shall we close the session?
Yes, thank you once again. Yes, thank you once again to everyone. So stay home and stay safe.
Yes, thank you.
Thank you, sir.